All right, so we're going to do lesson 34 and lesson 35 together. Lesson 34 is on page 138, and it is called the greatest common factor. And I've always loved doing these. And when we talk about the greatest common factor, we're talking about factors. We talk about prime factors of a number. 210, the prime numbers are 2 times 3 times 5 times 7. Those are called numerical factors. Numerical factors. That's pretty simple. Now we talk about literal factors, though. We talk about literal factors, then. We're also going to be talking about the letters. So if I gave you the term 210xy squared is e to the third, that would give you 2 times 3 times 5 times 7, those numerical factors, plus the letters. And that's pretty helpful, useful stuff. So the definition of greatest common factor: 2 or more terms and the product of all prime algebraic factors common to every term, each to the highest power that occurs in all the terms. So it has to occur in all the terms. So when we talk about algebraic factors, we're talking about both numerical and literal factors. So in the expression 6x squared y squared m squared plus 3x y to the third m squared plus 3x to the third y squared, what you're really talking about is 2 times 3 times x times y times m plus 3 times x times y times y times y times m plus 3 times x times x times x times y, breaking it all down. So all 3 terms, the biggest numerical factor I have is 3. That is in common with all of them. And in all of these, I have at least one x. And then I have at least 2 y's in each one. But notice my third term does not have any m's, so I leave m out, because there's no greatest common factor for m. So whether or not I write everything down, it's sometimes handy, and eventually you'll get used to not doing that, but there'll be a time when you're going to want to really do those things. So here's the first one. Let's pull stuff out of this one. Well, my numerical factor is only going to be 2 for my greatest common factor. Now look at my x's. I have 2 x's, I have 3 x's, and I have 2 x's, so x squared. I only have one y, but there's a y all the way across, so I'm going to use that. Now I have as many as 15 p's, but that doesn't matter when you only got one p over here, and there's a p in all 3 of them, so I can use the one p. And that's done. And that's the greatest common factor. Please do practice A, B, C from lesson 34. Okay. Lesson 35 is factoring the greatest common factor. And then we'll move on to canceling. Factoring is the process of pulling out the greatest common factor that we can later multiply back into. It's like, well, why do we do this? Well, this is really fun stuff, and you'll find out why we do this later. But for right now, let's have some fun with it. So I gave you 2 terms. What do we have in common? Well, we got a 2 in common, and we have an a in common. And x's are not in common. So what do we write in our second set of parentheses? We're going to write x plus c, and it's done. So we can write our problem as 2a times x plus c. Done. Pretty easy, pretty cool stuff. Now we can also have a problem that looks like this: a to the third x squared m squared plus a squared x m to the third minus a to the fourth x to the third m squared. Okay, a lot of stuff going on, and I would recommend to you that you break this out. And as you break it out, double check. I actually did this video once already and made a mistake, and I just decided it would be much easier just to go back and redo it, because when I made the mistake, I made a mistake of leaving something out that I shouldn't have. So it's important to double check these. 4 A's, and I'm going to switch colors because I'm running out of room and I don't want you to not see them. 3 X's, M, and M. Okay, that's the only reason why I switched colors. All right, so let's factor this out. Okay, what can I pull out of all of this? That's the same. Well, I could pull up to 2 A's out. And in fact, as I pull them out, I'm going to cross them off. Okay? I can pull out of here at least one X. So I'm going to cross off an X in all 3 of these. And I could pull out 2 M's because all 3 of these have at least 2 M's. So M squared, so I'm going to cross off 2 M's. Now, eventually, you might learn to do this without, I messed up my screen, so I was trying to fix it. You might learn to do this without having to write all this stuff out, but for right now, it's probably best if you do. All right, so here we go. We have A. That's what I have left. And I have an X left on my first term. My first term is gone because I wrote it down, so I'm going to cross them all off so I don't go back. In my second term, all I have left is an M, so I'm going to write plus M because it's plus over here. Then I'm going to write minus because it's negative. Negative, minus. I have 2 A's, A squared, and I have 2 X's, X squared. And I have factored out the greatest common factor. Now, if I apply the distributive property to this problem, I could, in theory, redistribute it and get the same answer. So it's pretty helpful to do that. So I would recommend, for now, write everything out. Eventually, you can probably get away with not doing that, but you're not there yet. And even if you think you are, you're not there yet. All right, so let's write it all out. 2 times 2 times A times A times A times B times B times B times B times Z times Z times Z plus 2 times A times B times Z times Z times Z times Z. Double check to make sure you got everything in there that you should have. And then what can you factor out of this? Well, I could take a 2 out of each of these things, right? So I'm going to pull a 2 out of there. I could pull 2 A's out of both of these. So I'll cross off a 2 before I do anything else. I'm going to A squared, so AA, and I could take a B out, so B, cross off a B, cross off a B, and I could take 3 Z's. Z, 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 Z. Done. So what do you have left? What you have left is you have a 2, and you have an A, and you have 3 B's, and then you have only 1 Z, and it's plus Z because it was positive. And you're done. You just factored the whole deal. Now, if you think you can get away without writing stuff out, this is what you would do. 6A squared X squared plus 2A, just lost my train of thought. 2A to the third, X to the third, plus 4A to the fourth, X to the third. Okay, you can certainly factor all this stuff out too. Okay, what can I take out of this? Well, if I'm looking, I can take a 2 out of all of these. Now you got to keep track of stuff. Okay, so to keep track of it, then you could pull out an A squared and an X squared. Okay, I pulled out all that. What does that have? What I have left? Well, 6 divided by 2 is 3. My A's are gone. My X's are gone. So that's all good. Then I look at my second term. The 2 is gone. I have an A left, and I have an X left. In my last term, I have a 2 left. I have 2 A's left, and I have an X. That leaves me with my final answer, and my problem's done. Now, you need to be very careful on this last set here, because it's really easy to get this stuff wrong. I want to make sure you do this right. 3m to the third x y squared plus m squared y. And you're like, oh, this looks easy. Okay, well, what are you going to pull out of this? Let's look. Well, I'm going to pull m squared. That's it. and I'm going to pull out y. Okay, m squared y. What does that leave me with? Now be very careful here. 3m xy, because I had one left on each of those. Notice that my second term is gone, but it's not gone. It's actually 1. It didn't become 0. I factored out of it. And remember, when you divide by the same number, you end up with 1. So make sure you're very, very careful not to leave that spot blank, because it's not 0. It's not blank. It's still there. It's just 1. Okay, so just keep in mind, you need to be super, super careful on those. And the very last thing that we're going to do today is called canceling. And we've been, to an extent, doing this. We solve this problem. You divide by 4 on both sides. You get x equals 5. You could cancel a little bit because you cancel out those 4s, right? All right, so because you've canceled out those 4s, you can do something else. That x equals 5. So cancellation or reduction to 1 is possible when the numerator and denominator contain one or more common factors. So let's take a look at this. Let's practice some of this. A minus 3 divided by 4. What do you have that you can cancel out? The 4, you get a minus 3. 3x minus 2 over x minus 2. What can you cancel out? X minus 2. You're left with 3. I don't know why I was trying to scribble the wrong thing. All right, and it gets a little more complicated. 3p plus 3 divided by 3. What can you cancel out? 3 and 3. You end up with n3p plus 1. That 3 can cancel out both of them. But remember that 3 doesn't go away because 3 divided by 3 is 1, so it's p plus 1. So let me get a little more complicated. 3x minus 9x squared over 3x. What can you take out? 3x. Part of that. So you end up with, when you end up doing that, you got to be really careful. You end up with 1 minus 9 divided by 3 is 3, and x squared divided by x is x. 1 minus 3x. So please don't forget that 1. 5x minus 25x squared over 5xy. Okay, what can you cancel out? Well, just be careful with this one. You can cancel out. Let's do this to make things simple. Let's factor. Let's factor out the 5x. So what do you have left when you factor out the 5x? You have 1 minus 5x. Really be careful about factoring out that 5x. The reason why I want to do that is because I'm going to do this. And that way, when I factor out my 5x and I do this problem, I'm going to cancel this 5x and this 5x. And in my parentheses, that's going to stay the same because I already factored out the 5x. And I can't cross out this 5x because I already factored it out. And if you look over here, I would have divided 25 by 5. I still have 5 left, so it's not 1. So what I have left is 1 minus 5x, and don't forget the y. So try A through D, and we are